Alright, welcome to Chapter 17, 17.2, Dosages based on ideal weight. So the ideal body weight, IBW, is unique for each individual and based upon many things such as weight, height, gender, body type, body frame, and age. Use a medically accepted IBW calculator to determine the IBW when needed. So for the first example, geriatric patient's body generally has a decreased portion of lean body mass and water. Along with an increased portion of body fat. These proportions alter the distribution of drugs. Some water-soluble drugs are strongly bound to lean tissues. Because the elderly have less lean tissue, more of these water-soluble drugs remain in the circulating blood, period. Higher levels can lead to toxicity. For the medications that are strongly bound to lean body tissue, calculate an overweight patient's dose based on ideal body weight, not actual body weight. For the medications that are strongly bound to lean body tissue, patients whose weight is below ideal, the actual weight should be used. Alright, so determining safe dosage based on ideal weight. First, check the package insert or product literature. Second, determine if the dose is safe based on renal function and ideal or actual body weight. Third, determine if the dose based on actual weight. Fourth, if the dose is safe, calculate the amount to administer. Alright, so here's our example. Example 4. A 48-year-old male, 5 feet 4 inches tall and weighing 180 pounds, is given the following order. He has normal renal function and is being treated for a serious but not life-threatening infection. Ordered garamicin, I'm hoping that's how I pronounce it, 70 milligrams IMQ8H. On hand, garamicin injectable 40 milligrams per milliliter. Alright. Okay, so first off, according to the package insert, for patients with normal renal function, the actual dosage for serious infections is 1 milligram per kilogram Q8H. Alright, and then after that, we have the dosage for obese patients should be based on the lean body mass. So if we were to use an IBW calculator, we would find out for a patient that is 5 foot 4 inches, the ideal body weight is actually between 122 and 157 pounds, which means that our person here, who is 180 pounds, is overweight. So our patient is overweight. Alright, so we know, according to what we learned before, is that for a patient whose weight is above what it should be, so if they're overweight, what we're going to do is calculate the dose based on the patient's ideal weight. So calculate dose based on ideal weight. Okay, so our interval for weight is between 122 and 157, so let's go ahead and calculate using those. So 122 pounds per 2.2 kilograms per pound. It's going to end up equaling 55.45, which we can round out to 55 kilograms. Okay, multiplying that by the 1 milligram per kilogram, we'll end up with 55 milligrams. Alright. And then let's go ahead and use the 157, which is the other bound for this person's weight range. 157 pounds. Converting that with the kilograms. 71.36, which we can round out to 71 kilograms. Multiply that by the 1 milligram per kilogram, and we will get 71 milligrams. Alright, so let's go ahead and compare the dose that was ordered. So the dose that was ordered was 70 milligrams. And 70 falls right in between 55 and 71, so we know that this is a safe calculation. It falls in between the range for the ideal weight of this person. Alright, so we know it falls into the safe range. So last thing we're going to do, since the dose is safe, we're going to go ahead and calculate the amount of the medicine that we want to administer. Okay. We'll go ahead and use the formula. A equals D over H times Q. D, remember, being the dose ordered, H the dose on hand, and Q is the unit. We can go ahead and plug in what we have. So A is going to equal, well, the dose that is ordered was 70 grams. Let me go ahead and put that on the side so we can see that. D is 70 milligrams. H is the amount we have on hand, 40 milligrams per liter. Milliliter, excuse me. And Q is the unit, which we have is 1 milliliter. Okay, we're plugging those in to our formula. So we get D, 70 milligrams. H is 4 milligrams per milliliter times Q, which is 1 milliliter. Alright, so then that's going to end up being, oh sorry, that's just 4 milligrams. That was the per milliliter. Okay, that'll end up being, let's go ahead and write it out on the side here. Simplifying out, we get 1.75 milliliters, which we could round out to 1.8 milliliters, squeezing that in right there. Okay, so let's go ahead and write our sentence. The amount to administer is 1.8 milliliters.